Folks, here we are in week 7. Welcome to your discussion post. Please have your calculus identification number ready. And looks like a couple spots. Actually, looks like there's 3 spots, your B, C, and D digits that we'll be using this week. So we have now transitioned from differential to integral calculus. And so with it comes a lot of new notation and ideas and rules. So let me see if I can set this up for you without going too far over the bounds. And but I certainly want to give you some, or at least an approach here to go through a problem of this sort. So let's see. Statement of the problem here. It says the volume of fuel in a tank changes at a rate given by the equation V prime T. So what you have here is at some point there was an equation that denoted the volume of fuel in a tank for some specific time, and somebody took the derivative of that function, and this is now explaining the rate of change. So this is how the volume of fuel changes over time in this specific tank, given by this equation, and it notes for time greater than or equal to 0. Let's see, at time equals the square root of D hours, is obviously D is from your calculus identification number. The tank holds 9 B from your calculus identification number gallons. What is the volume of fuel in the tank after C from your calculus identification number after C hours? Round the answer to 1 decimal place. So again, some explanation here of how you're using your calculus identification number to find these values that are applicable to this problem. So again, what we're talking about here when we go from differential to integral calculus. So, you know, just like addition and subtraction are opposite operations, and multiplication and division are opposite operations, the opposite of differentiation is integration. And so I have given you a statement here. It says, remember I said that there is some function v of t that we started with, and then we took the derivative of it. So what we want to do is we want to now go back and find that function v of t, such that when we take the derivative of v of t, we come up with this rational expression that you see here. It says, so we're looking for that function v of t such that when we take the derivative of v of t, we get v prime of t as shown here, and I note here as shown above. And this function that we're looking for is called the antiderivative of the first derivative. And the notation that we use to do the work, or to say that we want to find that antiderivative, is using this integration symbol. And so we're going to integrate this particular function, and so that we're finding the antiderivative. And this dt notation here again says that we're integrating, or we're finding the antiderivative with respect to t. One point I want to make here, I say that I'm finding an indefinite integral. As you go a little bit forward in these last 2 weeks, there's going to be times when we're going to want to know a numerical value for the integral itself, meaning, and we talk about the area under the curve, and typically we look at that on a certain interval, and so there will be bounds, a lower bound and an upper bound, that we would refer to as a definite integral. But here in this indefinite integral case, essentially what we're looking for is just the function form itself for the volume equation that is associated with this first derivative. Now, so I try U substitution. Let me just say this. There are, in any, whether it was, addition, subtraction, multiplication, division, or differentiation, there are lots of rules that must be learned. And I think the corollary to that in integration is that depending on the function that you are trying to integrate or find the antiderivative of, based on what that function is, there are many different approaches to integration or finding that antiderivative. But here, this idea of U substitution, I hope that you got from the reading. The reason that we're going to try this particular approach has to do with the fact that, well, I have a term here that involves t, and I have a term here that involves t, and there may be, I'll just say with a bit of a wave of the hand, there might be some magic in this in this U substitution method that helps us get rid of one of these t terms, and I will try to allude to that as I go forward here, again, without trying to do more than I should here, and just want to introduce this. So try U substitution, and I note here again, as the point I just made, integration methods come with experience, and that exclamation point and probably a smiley face as well, because it does take a while. So the U substitution that we're going to make here, notice in the denominator under this cubed root symbol, we have the expression t squared plus 3. So I'm going to let u equal t squared plus 3. So that is my u substitution. Then the next thing I want to do is, based on that definition of u, I want to find the derivative of u with respect to t. So in this step right here, all I want you to do is take this equation, find u prime or du dt. So take the derivative of t squared plus 3. In the next step, assuming, and it's probably best that you write this as du over dt, you're going to have equals whatever that derivative is. I want you to solve this for dt. So just an algebraic step to take whatever this derivative is, and in this step, you're going to solve for dt. Now, so I hope to this point everybody's following this, and I hope this makes sense to this point based on what you've read and hopefully what you've done in your homework. Now, once you have defined u, you have found the derivative of u with respect to t, and you've solved for dt. What I want you to do is go back to this step. I want you to go back to this step, and I want you to rewrite this antiderivative, subbing u for t squared plus 3. So instead of t squared plus 3, I'm going to have u, and subbing for dt. So where you have dt here, I want whatever you found when you solve for dt in this step, I want you to replace dt here with whatever you came up with here. And then once you have done that, I think you're going to see that there's a t in the numerator and t in the denominator that can be canceled. So if you do all of this correctly, what you're going to be left with is an antiderivative. So you're going to have the integration symbol, and all of this will now be in terms of u. Okay? Then next step. So using the rules of integration that you've talked about a couple rules to this point, I want you to actually do the integration step here. So just a quick hint here, what I believe you're going to have is what you're going to want to integrate is you're going to have a cubed root of u in the denominator. So if you were to maybe write that as u to the minus 1/3 in the numerator, you have rules for integration that will allow you to integrate that. So you have to do that very carefully. So use those rules for integration, take the antiderivative, and because this is an indefinite integral, you know that when you find the general form of an antiderivative, it comes with an integration constant. So don't forget to add your plus c at this point. So after you have found the general form of the antiderivative and you have added the integration constant, at that point you will basically have you'll have an equation that says v of t equals a certain function plus a constant. At this point, what I want you to do is I want you to go back, and where you substitute or where you have a u in that equation, and you should have it in one spot, I want you to replace it with t squared plus 3, and that way you'll write this as an equation. As we mentioned, you'll have the volume equation as a function of t. Now, at this point, that integration constant has to be solved for based on some given conditions. And there were two conditions in the statement of the problem that allow you to solve for the integration constant. It says at t equals the square root of d, again the d from your calculus identification number, at t equals the square root of d hours, the tank holds 9.b gallons. So what we get from that is the fact that once you write this equation v of t equals at t hours, so on the right hand side of this equation you will have a term involving t where you're going to substitute whatever the square root of d happens to be for you. So you'll substitute here for t, and it says the tank holds 9 point blank gallons, where the blank here is your b. So that will be the actual v of t. So this equation then, in order to find the integration constant, becomes 9 point b, whatever your b is, equals the general form of the antiderivative where you have substituted the square root of d for t. And at that point, once you have done that, the only thing that'll be left in that equation in terms of a variable is the integration constant c, and you can solve for the integration constant c. Now, once you have done that, you can rewrite the volume equation v of t equals whatever it is involving t, the general form with t, and then you have substituted a numerical value for your integration constant. And then finally, you can answer the question that's originally posed. Find the volume, the original question here, what is the volume of fuel in the tank after C hours? So once you have substituted, done everything to find the integration constant, you have the volume equation, you can substitute your value of C for T, and then you can find the volume after C hours. So again, there's a lot going on here, and again, I hope I did or offered more help than harm here by offering these steps. But again, I don't want to overstep my bounds in terms of what I should say, other than if you take these or follow these steps, I think that is a very methodical approach to get to that. And it's also the necessary steps to correctly get the antiderivative, solve for the integration constant, and then finally answer the question that you're being asked here. So again, let's clean this up or finish this up by just talking about the rubric. Again, looking for a best effort in your initial post. Again, a lot going on here, but follow those steps and you'll be in good shape. If there's any work that needs to be redone, I'll let you know within 24 hours. And make sure your work is done in an equation editor so that it looks neat and professional. And that will be a wrap on this. So again, a lot going on here this week. I hope I've given you some good hints on how to proceed and get through this. If you need some help, let me know. Otherwise, I look forward to a lot of good discussion posts on the board. Have a great week and take care.